Hi, it's Tech Trailblazer. Welcome to our new series. Today in this video we are going to see typical intelligent agents, fully observable versus partially observable, episodic versus sequential, discrete versus continuous. Agents in artificial intelligence. An AI system can be defined as the study of the rational agent. It is a computer program and uses logical reasoning and ability to make decision to determine its following action, chess playing, and its environment. The agents sense the environment through sensors and act on their environment through actuators. An AI agent can have mental properties such as knowledge, belief, intention, etc. What is an agent? An agent can be anything that perceive its environment through sensors and act upon that environment through actuators. An agent runs in the cycle of perceiving, thinking, and acting. An agent can be human agent. A human agent has eyes, ears, and other organs which work for sensors, and hand, legs, vocal tract work for actuators. Robotic agent. A robotic agent can have cameras, infrared range finder, NLP for sensors, and various motors for actuators. Software agent. Software agent can have keystrokes, file contents as sensory input, and act on those inputs and display output on the screen. Hence the world around us is full of agents such as thermostat, cell phone, camera, and even we are also agents. Before moving forward, we should first know about sensors, effectors, and actuators. Sensor. Sensor is a device which detects the change in the environment and sends the information to other electronic devices. An agent observes its environment through sensors. Actuators. Actuators are the component of machines that converts energy into motion. The actuators are only responsible for moving and controlling a system. An actuator can be an electric motor, gears, rails, etc. Effectors. Effectors are the devices which affect the environment. Effectors can be legs, wheels, arms, fingers, wings, fins, and display screen. Intelligent agents. An intelligent agent is an autonomous entity which act upon an environment using sensors and actuators for achieving goals. An intelligent agent may learn from the environment to achieve their goals. A thermostat is an example of an intelligent agent. Following are the main 4 rules for an AI agent. Rule 1. An AI agent must have the ability to perceive the environment. Rule 2. The observation must be used to make decisions. Rule 3. Decision should result in an action. Rule 4. The action taken by an AI agent must be a rational action. Rational agent. A rational agent is an agent which has clear preference, models uncertainty, and acts in a way to maximize its performance measure with all possible actions. A rational agent is said to perform the right things. AI is about creating rational agents to use for game theory and decision theory for various real-world scenarios. For an AI agent, the rational action is most important because in AI reinforcement learning algorithm, for each best possible action, agent gets the positive reward, and for each wrong action, an agent gets a negative reward. Rationality. The rationality of an agent is measured by its performance measure. Rationality can be judged on the basis of following points. Performance measure which defines the success criterion. Agent prior knowledge of its environment. Best possible actions that an agent can perform. The sequence of precepts. Structure of an AI agent. The task of AI is to design an agent program which implements the agent function. The structure of an intelligent agent is a combination of architecture and agent program. It can be viewed as 1. Agent equals architecture plus agent program. Following are the main 3 terms involved in the structure of an AI agent. Architecture. Architecture is machinery that an AI agent executes on. Agent function. Agent function is used to map a precept to an action. F-ton poking smiley asterisk. Agent program. Agent program is an implementation of agent function. An agent program executes on the physical architecture to produce function f. P's representation. P's is a type of model on which an AI agent works upon. When we define an AI agent or rational agent, then we can group its properties under P's representation model. It is made up of 4 words. P. Performance measure. E. Environment. A. Actuators. S. Sensors in designing an agent. The first step must always be to specify the task environment as fully as possible. Properties of task environments. Fully observable versus partially observable. Deterministic versus stochastic. Episodic versus sequential. Static versus dynamic. Discrete versus continuous. Single agent versus multi-agent. Fully observable versus partially observable. If an agent's sensors give it access to the complete state of the environment at each point in time, then we say that the task environment is fully observable. A task environment is effectively fully observable if the sensors detect all aspects that are relevant to the choice of action. An environment might be partially observable because of noisy and inaccurate sensors or because parts of the state are simply missing from the sensor data. Deterministic versus stochastic. If the next state of the environment is completely determined by the current state and the action executed by the agent, then we say the environment is deterministic. Otherwise, it is stochastic. Episodic versus sequential. In an episodic task environment, the agent's experience is divided into atomic episodes. Each episode consists of the agent perceiving and then performing a single action. Crucially, the next episode does not depend on the actions taken in previous episodes. For example, an agent that has to spot defective parts on an assembly line bases each decision on the current part, regardless of previous decisions. In sequential environments, on the other hand, the current decision could affect all future decisions. Chess and taxi driving are sequential. Discrete versus continuous. The discrete/continuous distinction can be applied to the state of the environment, to the way time is handled, and to the percepts and actions of the agent. For example, a discrete state environment such as a chess game has a finite number of distinct states. Chess also has a discrete set of percepts and actions. Taxi driving is a continuous state and continuous time problem. The speed and location of the taxi and of the other vehicles sweep through a range of continuous values and do so smoothly over time. Taxi driving actions are also continuous, steering angles, etc.